This is part 4 of 7.1, and this is absolutely as ugly as they can get. We need to divide these two and then multiply here, and all 6 pieces of this needs to be factored as much as possible. Okay, so let's just get started. Okay, I'm going to come over to the side, and like I did on the previous problem, I'm going to factor here and then basically use that as bookkeeping, and then I'll rewrite this in factored form. So if I start off with 2x cubed plus 3x squared minus 2x, and I want to factor this as much as possible, I see that I have an x in each of them, so I can factor out that x. I have 2x squared plus 3x minus 2 left. Okay, now I need to see if this factors any further. I do not have squares on the ends. There's still not another GCF, so I did factor out the largest thing. I'll be looking for two numbers that multiply to a -4 and add to a +3. So that's 1 and 4, with the 1 being negative. Yes, that's right. So I still have this x, and then I'm going to rewrite this 3x as 2x squared minus x plus 4x minus 2. And now we can group. Don't lose the outside x. For my first group here, I can factor out an x, leaving 2x minus 1. Here I can factor out a 2, leaving 2x minus 1. So this whole thing factors as x times 2x minus 1 times x plus 2. Okay, so my first fraction, the numerator, looks like this. Okay, now look here. This is an easy factoring. The only thing this has is a GCF. I can factor out a 3, and that leaves me with x minus 5. Okay, divided by. Here, I can factor out an x squared. If I factor out an x squared, that leaves me with 2x minus 1. And there's nothing else that factors here. So this is x squared times 2x minus 1 over. Okay, so that's 3 things factored. Now let's work on x squared minus 3x minus 10. Okay, I don't have a GCF. I don't have perfect square. So I'd be looking for two numbers that multiply to a -10 and add to a -3. And -5 and +2 will work. So this factors as x minus 5 times x plus 2. And remember, I got to use the easier form of this because the coefficient here was a 1. Up here, the coefficient was a 2, so we had to use the other method. So this is x minus 5 times x plus 2. Okay, times. Right here, I can factor out a 5x, and that leaves x minus 2. So that's completely factored. For this one, I can factor out a 3, correct? If I have 3x squared plus 12x plus 12, I can factor out a 3, and that gives me x squared plus 4x plus 4. And I need to see if this will factor any further. I have perfect squares on the ends, so let's check to see if it's a perfect square trinomial. The square root of x squared is x. The square root of 4 is 2. If I multiply these two things together, I get 2x. And then if I double that, I do get 4x. So this is a perfect square trinomial, which means that this factors as 3 times x from right there plus 2 squared. And I've just rewritten that in that denominator. Okay, So now everything is factored. I'm just going to concentrate on the fraction part now. Keep this one, flip this one. I'm working on the parentheses first. Again, anytime you have a recopying step, slow yourself down. Make sure that you are not making a stupid mistake. Okay, so I kept this one, change it to multiplication, and then we're going to flip this one. And this is a multiplication, and I'm not even really worried about it yet. I have another step coming to deal with this, so it's just a recopy. Okay, so now inside the parentheses, let's look for things we can cancel out. I do not have anything, this fraction by itself does not reduce, neither does this one. If we look on diagonals, I have an x minus 5 here and an x minus 5 here, so those can go. Here I have a 2x minus 1, here I have a 2x minus 1, so those can go. Okay. Here I have 1x, here I have 2. So this 1 cancels out one of those. Okay, so I think that's it for that one. Let's multiply straight across. I have x plus 2 times x plus 2, which is x plus 2 squared, over, I still have a 3, and I still have an x. Okay, so this whole thing is this. All of this is that. Now I'm going to recopy this. And we look for cancellations. I have x plus 2 squared on both of these, so those cancel out completely, and so there's a 1 up here still. And we have one more cancellation. Here we have an x, here we have an x. So those x's go away. So what do I have left? 5 times x minus 2 over 3 times 3, which is 9. And this is your final answer. They're not going to ask that you distribute here unless it would end up with some major cancellations and simplifications, but that doesn't happen here. So this would be your answer. That's as nice as that one gets. I expect that you were able to follow along with all of these steps. This is more difficult than something I would give you on a test by far, but you can see that we're doing the same steps we did before. There's just more of it. I make a distinction between a harder problem and a longer problem. This one's longer, not necessarily harder than some of the others we've been doing.